Yesterday, we're going to start with observations. Okay, we're going to start with observations about the moon. And we're going to see if we can use those to come up with some theories of how the moon was formed. So what do we know about the moon's history? Okay, so first of all, it formed around the time of the Earth. And when it first formed, it was a hot, dense, molten surface.
Can you turn your phone off?
Okay, so it's a hot, dense, molten surface. Okay, so like the whole surface of it was like magma. Well, lava, but like the whole surface of it was. So then it cooled. On the surface. Okay? Then it was hit by a bunch of craters. Yep. Sorry. Hit by a lot of asteroids. Thank you. So hit by a bunch of asteroids. Okay. Large collisions. Released magma, because the center is still hot at this point. Magma, not MAGA. Magma from under the surface. Those are called Maria. Which I'll show you examples of these here in just a second. Okay. And then there's some more. So the moon cools. And more asteroids. And then we're at now. All right, so let's look at this.
When I introduced him to Scientology standards.
Okay. No, that's not the one I wanted. Not yet. Let's see. Really, this is how we're going to be thing? I asked kindly for you to work. Anyway, I'll work on getting this up. Another thing, just to kind of look at these here. Okay, so here's what the moon looks like. You've probably noticed this before. So remember I talked about the Maria, where these areas where the large impacts happen, it released magma from the surface? That's what these dark spots are. Okay. So these dark spots, if you're wondering, well, why are they so much darker? Because it's lava rock, right? Like, why are the beaches and the sand and the rocks in Hawaii black? Because they're basalt rock. They're like dry magma. That's what this is here. Okay, so that's what this is here on the surface. The rest of it is just kind of the regular cooled surface. Another thing that I think is interesting with this too is probably something you haven't seen, which is the other side of the moon. And the other side of the moon, oh my gosh. Other side of the moon looks like this. Yes. Okay, you'll notice the other side of the moon is pretty much just craters. And the reason for that is because that's kind of the older collisions that happened. Also, why would there be a lot more craters on the opposite side of the Earth? Or like the opposite side of the moon? Right, because the asteroids are coming from that side towards the Earth, and they're hitting that side. You may or may not know this, but the moon is tidally locked. That means the same side of the moon faces us all the time. It never changes. The same side of the moon is always going to face us. Okay, which is why we always see the same. That's why this is what we're used to seeing, and not this. Depends on if you're listening to Pink Floyd or not. If you're listening to Pink Floyd, it's very dark. If you're not, then it's just whatevs. Which one?
The one that we see.
This one?
No, the other.
This one? Yeah.
What's that at the bottom?
This is a big crater.
I think it's like cracking.
It's just spread out.
No. We've been trying to send missions to the poles lately, but we've been having not really any luck. And by not really any luck, I mean a lot of missions that have been sent there have crashed.
How do you crash? You should just get better. Yeah, you should let me go on.
So, okay. So let's look at some theories for how the moon was formed. So there are 4 theories on how the moon was formed. We're going to talk about all 4, but one is better than all the rest. So I'll make sure to point out which is the best one. So first theory from the moon is called capture theory. Okay, capture theory says this. The moon was basically a rogue planet. It's, roughly Mars-ish size. It's a little smaller than Mars now, but it was traveling through space, and we caught it in our gravity. Okay, so moon caught in Earth's gravity. Okay, moon was caught in Earth's gravity. This one is unlikely. Okay, this one's unlikely. The reason it's unlikely is because the moon's too big for that. Like, the moon is too big, it would have been traveling too fast. Earth's gravity is not strong enough to do that. So Earth's gravity probably is too weak. I mean, we can't say for sure that, like, Earth's gravity wasn't larger in the past, I guess. But as far as we can tell from our measurements, it would not have been large enough.
It's unlikely because you were there.
Well, I did see that, and that's not what happened. So, all right. So the first one is capture theory. That one's unlikely. Okay. Second one is called sister theory. And this one, the moon formed alongside the Earth. So they formed together at the same time. So of the stuff that was orbiting around, Earth swept up some of them, Moon swept up some of them, and they formed at the same time. Okay? This one is unlikely. I know. This one's unlikely. The reason is the composition, so like the composition of elements, is different. So there are, so like it's not like we find minerals like on the moon that are like completely like you don't see them anywhere else. But there are some metals and minerals that we see on the moon that are very uncommon on Earth, and we find them on the moon in larger quantities. So the composition is different. If they formed at the same time along with each other, they should be exactly like they should be really close to each other. Also, like, why is the moon picking up stuff and the Earth's not pulling that on? Like, that also seems unlikely. The next one is daughter theory. Basically, the moon broke off from the Earth. Okay, so the moon actually got like ripped off of the Earth. This one, you'll be surprised, is unlikely.
What?
I know. This one's unlikely. The reason this one is unlikely, first of all, this composition issue is also a problem with daughter theory. Because, like, why are the compositions different if it just got ripped off of the Earth? It should be almost the same, right? So that's a problem. Another problem is how? Like, how did it get ripped off? Like, did it just magically...
You picked it up. Yeah, Mr. B, you did it.
I did. That's right. I came over and whoop, threw it into space.
You're out.
Yep.
You know, I feel like you would normally remember this.
I mean, that
Yeah.
was billions of years
You
ago.
would think. Well, that's true. My memory isn't what it used to be. So that brings us to the fourth one, which is called impact theory.
Yeah, by another planet. By another crazy.
Okay, so a Mars-size planet collided with Earth. And this one is likely. Finally. Okay? And this is, it matches observation. Like, what we observe, this one matches it the best. Okay? That's not to say the other ones don't match some of the observations, but this one seems to match all the observations the best. This would explain why the compositions are a little bit different, because it would have been made up of different stuff when it collided. It would have given some of that stuff to Earth, but it would have kept some of the stuff to itself. Earth's gravity is not really necessary in this case, because it would just been they were on a collision for each other. Earth might have pulled it in a little bit, but they just kind of smashed into each other. we have an explanation of how that would actually happen. So this is the one that seems to make the most likely logical sense for what's going on. All right, so I need my Earth and my Sun back.
Oh, get up there.
And then I need someone to be the moon. I need a moon. Reach you the moon? Or reach you the moon. Okay, here's the sun.
Wake up.
Here's the Earth. Come back, Earth. Okay. There's the power of the Earth. Okay, so Earth, come up here.
I want to be the sun.
No, not the sun. Sun, go stand at his desk. Moon, come on up here.
You want my sunshine?
Okay, go ahead and turn the sun on. There goes the sun. All right, put the moon kind of up here, not right in front of the Earth, but kind of up there. Okay, so right now, what type of moon phase would this be? A new moon, because it's during the day, and the opposite side of the moon is what's facing. Okay, the opposite side of the moon, that's what's facing the sun. Okay, so that's what's getting lit up. So now let's go ahead and keep the phases. So now you're going to come over here. Let's go to the night. Okay, and just like right there. Okay, so now, and very close to the Earth apparently. So now this would be a full moon, right? Because at a full moon, we can see it on the night side, and we're seeing the full lit up portion of the moon. Okay, so this would be a full moon. So what causes the phases? The phases are caused by the moon's motion around the Earth. So if we count the new moon as day one, it orbits around the Earth. Okay, now the Earth's rotating, but that's not necessarily important. The moon's orbiting around, and as the moon orbits around, we can see different parts of what's lit up. So if you put the moon over here now, you can see, and kind of shine on both if you can, Reese. You can see that this part is now lit up, and that's what we can see. And the time we see it is kind of in the morning, as we're getting ready to see the sunrise. So that explains why the moon rises and sets at different times. It explains why the phases are different, because it has to do with the moon's position around the Earth. Now, let's talk about eclipses. So the moon does not travel directly in front of the Earth very often. The moon kind of makes this like pattern here around, so that it's passing, but it doesn't really cast a shadow on the Earth. Okay? So as it goes around, that's what the moon is doing. However, sometimes the moon, that dastardly moon, gets in the way. So go ahead and put the moon right in front of, no, not your hand, the moon. You've got to have the moon only there. You can't, excellent. Yeah, there's a little bit of hand, that's all right. Notice that right now, there is, go lower. Right now, there is a big spot on the Earth that is covered up by the moon. That is a solar eclipse. On a solar eclipse, there is a portion of the Earth that is completely covered up by the sun. Interestingly enough, the reason for that is because the moon and the sun are almost exactly the same size from our perspective. Okay? So the size of the moon in the sky and the size of the sun in the sky is identical. It's the same. Okay? So, for that brief time that the moon is in front of the sun, it covers up the sun, and part of the Earth is covered by that shadow, and that's called an eclipse. Okay, that's what we had last year. Now, Earth, step up a little bit, moon go behind, and go ahead and put the moon all the way behind the Earth. Now, at this point, it's a full moon, but it's completely blocked. I'll do this real quick. It's completely blocked. This would be a lunar eclipse. This is what happened earlier in the year, where the sun is blocked by the Earth, and you can only see the light that bends around the Earth. All right, good job today, guys. Thanks. Yeah.
So I heard that we see this moon just as long in the day as we do in the night. Like sometimes we won't see the moon, like on a new moon.
No, so you actually can see it. If you look really carefully and you know where you're looking, you can see like a brief outline of it. So it's not that it's not there. It's not that it's not visible. It's just that you see so little of it that it's hard to make out.
What about the part that's saying you see it equally during the day and night throughout the year?
Now you see it equally?
Yeah.
Yeah, because the Earth's rotation is constant.
What if I have night vision goggles?
Ooh.
You'd probably go blind.
Enjoy.
This isn't very constant.
Will my teacher count me late?
Yes.
Mine
We'll
won't.
find out.
You the doctor won't. I'll be back.
Okay, so here is the light coming from the sun. This would obviously be the day side of the Earth. And this would then be the night side. So that light from the sun is going to reach the moon over here. So it's on the night side. It's going to reach the moon. It's going to light up that front side of the moon. Here, it's also going to light up that side of the moon. But notice that so this would be a full moon. But from our perspective, when we're looking at it, we can only see half of it lit up. We're going to see this side is dark, not lit up. We're going to see this side is lit up. Over here, again, the front is lit up, but we can't see that. We're going to see only the dark side, and then we'll see the opposite over here. Okay? So this is a full moon. This is called a last quarter. This is a new moon. This one's called first quarter. Okay, so the phases of the moon caused by the moon's position, and then what causes the solar and lunar eclipses? So the eclipses are caused by either the moon getting in front of the sun or getting behind the Earth. Okay, so if the moon gets directly in front of the Earth, it's going to project a shadow down onto the Earth. And that is going to be your area for the solar eclipse. But if you're talking about the moon being on the other side and it being in Earth shadow, then the Earth would create. So the Earth would create a shadow. So this one would be a solar eclipse. This would be a lunar eclipse. And this is like the lunar eclipse that we just had recently.